Welcome to the part 3 of this video series. In the last video, we secured our gateway with API key authentication middleware. But now we have another problem, and that is success. It might sound funny to some of you guys, but imagine your user service gets popular, thousands of requests every millisecond or every second. So if we have only one instance of our backend running, let's just say on port 8081, it is going to fail under heavy load. It's a single point of failure. So how do we fix that? You might ask. So it's called horizontal scaling. We spin another server, another instance of our backend. But now the question arises how the client is going to know which backend to connect to. So this is the topic for our video of today's video. We are going to implement a load balancer, which is going to distribute our load across the instances of our backend evenly. So yeah, let's get into it. To implement our load balancer, we are going to use a round robin algorithm. Round robin. What this algorithm does is basically, let's imagine we have 2 or more servers and we receive requests every other second. So what this algorithm is going to do is distribute these requests evenly on these servers. Let's just say request 1 to the server 1, 2 to the server 2, 3 to the server 3, and again 4 to the server 1. So this is basically a round robin algorithm. Now the problem we face is to implement this round robin algorithm, we are going to have a counter variable, and this counter variable we will face, let's just say, imagine we have this counter set to 0. We haven't started taking any requests as of now. So request 1 comes and it tries to increase it to 1, and at the same time request 1 is reading from it. So it is going to cause a race condition, which eventually leads to uneven distribution of requests on our servers. So one server might get extra load because of this race condition. So the naive way to fix this problem would be using mutexes. Now, what are mutexes? These are basically a lock type of thing. We lock our certain part of our code, which can be only accessed if a request has a lock. Let us say request 1 has a lock. So request 1 has the authority to change this variable, and only request 1 can change this variable, and no other request can even read from it. Only after releasing the lock, once the first request releases the log, other requests can read from it or write to it. So this is very performance intensive task. So, and in our high performance gateway API, we don't want to have this really intensive task because we are going to serve multiple thousands of requests every second. So this starves every other request and makes the operation overall slow. So we are going to handle it a low level way. And what do I mean by this? We'll get to know in the next section of this video. Now let's look at our code. We are going to change this URL to URLs, and now we will add these two backends. And 8083. Now this service, user service, points to these two URL, list of URLs. This is basically how we tell our gateway that our service is load balanced. So let's now look at our code. So let's get into it. Let's see how gateway.do. And now we need to change this to URLs, and it would now be an array of strings. And let's just change this to URLs. And also we'll need to have multiple proxies. So proxies, and it will to be an array, but of HTTP util reverse proxy type. And let's see our new gateway function. And in this we can see if current service dot URLs are registered. Now if we check the length of our current service dot URLs is equals 0, we can just log dot printf and say service percentage f does not have any URL defined, and we can return like. And now let's just remove this part. Let's remove this part, and let's just range over our this current service. For and I equals 0, I less than of current service dot URLs, and I plus plus, and we can now have a target URL. Let's just paste our current service dot URLs dot file, and if else is not equal to null, we'll return null, and our will have a variable called proxy there, and that will be http util dot new reverse single host reverse proxy target, and we will then append it to our name, current service dot proxies equals to append our target. Sorry, proxy. So this is how our new gateway function will look. What we did was first we checked if there is any check if there is any URL provided for our service. If there's none, so we log this out and return a nil. And if there is one or more services, we loop through it and create new target, and we create a new proxy using that target, and in the end we attach it to our new proxies arrays, which will hold every backend for our service. So this is it for new gateway function. Now we also need to change a few more functions. Let me see what needs to be changed. So yeah, this handle gateway also needs to be changed. And so now we need to fix this handle gateway too. Instead of proxy, we can create a new function called new proxy, which will return us a new proxy every time we hit our request. So let's just create it here. Also, we need to add a counter variable. Let's just say count here. Count of type int. It will be unsigned int 64. So to implement this new proxy function, we will have a function on our service. It will get actually our service, and it will be called new proxy, and it will return us at 12, return us and http util dot reverse proxy. And now this is the low level part I was talking about to handle our high performance gateway API. Mutexes would be too computationally intensive to use. It will star other processes, other requests. So we will use this standard library in Go called atomic sync.atomic. Let's just say increasing, let's just say our counter s dot count plus plus. So this basically splits into three instructions. First, we need to load this count in our register. Then we will increase it by 1, and then we will replace our count to this new count value. So it basically is three-part process, which is computationally intensive. So we will use sync.atomic uh, module, and what it does, it directly talks to the CPU, and it does this same thing in one cycle. It locks and simply adds uh, add add whatever value you intend to this variable. And so yeah, this is it. And let's just save it in action. Uh, Let me call it new val, and it would be equal to sync dot atomic sorry atomic dot add int 64, and we need to pass uh, our pass the reference to the s dot count and increase it by 1. When we see this function's definition, you add uint64 automatically adds delta to this address and returns a new value to subtract a signed positive constant from C from X. So yeah, yeah. So this action basically is really low level and really fast, and we also have no business to use mutexes. So let's just see how we will have an index. So index would be, let's just say, our new value would be modulus of uh, length of our s dot proxies, and then we can return s dot proxies index. Uh, uh, Sorry, mismatch type uint64 and int. What is this is of typing? We might wrap it in uint64. Let's see if that fixes the problem. Yeah, it does. So this will add this count to 1, and we will get like 0, 1, 0, 1, basically hopping between these two backend servers. I think everything is almost done. We need to remove this. Is there anything else? Any other error we need to fix? Oh, sorry, I didn't add this. Current service dot me. Yeah. This is it. Now what we need to do, we need to create another backend. Capital D, sorry, D, back and 3, and in the backend 3 we need exactly for the backend one. Backend 3. Let's create a new file. Backend.go. I paste this, and let's start this on server 8083. Hello from backend 1, running on port 8083, and let's just change this backend one also. Running low from backend 1, running on port 8081. Let's now test our new application. Teams. Go run backend 1 backend.go, and go run backend 3 backend.go, and now let's run our gateway. Go run gateway.go. Service product service does not have any URL defined, so we are not going to hit product service as of now. So let's just test our thing, and yeah, so empty reply for server. What is the problem? Service product does not have any URL identified, panic serving, runtime invalid memory address or null pointer differences. References. Let us see. Uh, uh, mm, uh, server.go find service gateway.go. Uh, mm, so we have this service. This does not have any URL defined. Service product service does not have any URL defined. And after that, our program panics. So what happens after this? We return a null. So we return null to our gateway. Hmm. Oh, so this value becomes null, and then it tries to do operations on this null. So this is causing it to panic. So there are two options. Either we have either we add services to the new URL, or maybe we can return, sorry, where is it? Here. Either we return gateway, we are now returning gateway. We can also return gateway comma errors, or we can have uh, multiple URLs and product services also. Let's just see if our YAML.config, if we change it to, oh, it will also not pass. So this blender in here, so we need to change this also. And let's just add HTTP localhost 8082 HTTP localhost 8082. I think this should work now. And also add this auth API to the users. I think this should do the job now. Let's just test it. We need to rerun our gateway. Let's just clear this flutter. Go run gateway.log. So yeah, registered middleware auth API key. And so yeah, let's now try to this user. Backend port 8083, now port 8081, port 8083, port 8081. As you can see now, it uses the correct round robin algorithm. It directs one request to the backend one running on port 81 and the other to port 8083. And let's just see if our authentication is still working. Let's just remove this one. So yeah, we get an authentication field. So yeah, and if we have this one, So as you can see, the load balancer also works. So yeah, this is it for today. And in the next video, we will see how to uh, implement logging and metrics using Grafana. We will include this in our next video. So until then, goodbye, take care.